Hello and welcome to the very first Geoscience Radio podcast. My name is Ben Walsh and I'm an exploration geologist with virtually all of my experience in unconformity type uranium. My experience in the industry is relatively limited. However, I often find myself, like so many other geologists, wondering what were the factors that led to that discovery. And when I look, I find almost no information. Here at Geoscience Radio, my goal is to bring those stories to the listener. Because discoveries don't come from singular moments of genius by prodigy geologists. Discoveries are realized by teams, and often made by years of hard work, by many people. We're going to look at the exploration, the techniques, the strategy, and the moments in time where, if it weren't for a second look, a deposit may have gone unnoticed. In this episode, we're going to be looking at the exploration and events that eventually led to one of Western Australia's more recent major greenfields gold discoveries, Tropicana. The deposit is located on the eastern margin of the Yilgarn Craton, approximately 330 kilometres east-northeast of Kalgoorlie, and is jointly owned by AngloGold and Independence Group. According to recent publications, the deposit has an inferred resource of 11.9 million tonnes at 2.83 grams per tonne for 7.89 million ounces of gold. Open-pit mining began in 2013, with the first 3 years forecast to produce between 470 and 490,000 ounces per annum. Today, we're going to be hearing from this man.
I'm Bruce Kendall. I'm currently the Chief Geological Officer with Blackham Resources. At the time of the Tropicana discovery, I was the Senior Exploration Geologist.
To start things off, there was one thing I had to ask. Where the name came from?
But was known by a guy who worked at the time for Independence Group, who's now runs Mapability, and he picked the name Tropicana because he thought it was the least tropical place he'd ever been to in his life.
Oh, right.
So,
okay. The story of Tropicana actually began on the other side of the world in 1993, with the discovery of the Voisey's Bay nickel, copper, cobalt deposit in eastern Labrador, Canada.
Western Mining were out there soil sampling. They were looking for another Voisey Bay. They're looking for a big magmatic nickel system.
What actually led WMC to the Albany-Fraser origin was its structural and lithological similarities to the crustal suture between the Churchill and Nain provinces, which contained this significant, newly discovered troctolite gabbro-hosted sulfide deposit. The identification of this geologically analogous origin led WMC to search for mafic intrusives within the Plumridge terrain.
And so they did really broad-spaced soil sampling.
2.5 kilometre line spacing by 5 kilometre composites with a sample taken every kilometre.
And they analysed for half the periodic table, obviously analysed gold.
This surface sampling campaign was designed as a broad-spaced geochemical survey to identify dispersed nickel, copper and gold anomalies. What was identified was a coherent gold anomaly of over 1 ppb in bulk cyanide leach and a similar response of between 3 and 7 ppb in heavy mineral concentrate. Ultimately, what was discovered was a 7 by 20 kilometre gold anomaly striking northeast, parallel to the Albany-Fraser origin. The following year, in 1998, more surface samples were collected across the gold anomaly. This campaign was completed at 1 kilometre line spacing with 1 kilometre composites with samples collected every 200 metres. And the result? A peak gold anomaly of 31 ppb, only a few hundred metres from what eventually became the Tropicana gold mine.
And that was in the mid-90s, and Western Mining were essentially packaged themselves up to sell. So anything was gold was of no interest. They wanted nickel. And reportedly, the geos said, we've got this soil anomaly, we should go and drill it. And they said, oh no.
So here we have an example of a relatively significant and coherent gold anomaly that was left untested. The reason for this divestment was partly associated with the gold price, which, in December 1997, was $288 per ounce. Adjusting for inflation, it was at its lowest point since February 1973. Gold was not sexy. So WMC is out of the game. The Pleiades project was shelved, and the entire group of exploration tenements was surrendered. However, one company's risk is another's opportunity.
the ground became vacant, and Independence Group, who was a new floated company, picked it up, and they had no money. And so they went around looking for partners and came into AngloGold, and AngloGold said, okay, it was interest. And the reason they picked it up was they thought it might be an inlier of Archean greenstone. Some of the guys drove out again. This is pre my involvement in the project. They drove out to the site, and there's very little outcrop, but there is one outcrop about 3 k's north of where the pits are now, and it's a big banded iron hill. And so they walked up to this hill and said, oh yes, there's banded iron formation. It fits our model. It's a greenstone inlier. So they picked it up on that basis.
Following the formation of the joint venture agreement in 2003, a shallow air core drilling campaign was designed and executed to complete a first pass test across this official gold anomaly detected by WMC. But the results weren't quite what the joint venture was hoping for.
And so there was a little bit of regional exploration drilling that happened in that period, not a lot. And they got some initially quite good numbers from air core, but they weren't earth-shattering. So they were expecting, the first drill holes, they were expecting to see sort of mafics, maybe felsics, maybe some sediments. They certainly weren't expecting to see gneisses.
What they found in air core and RAB holes throughout the prospect were amphibolite and granulite facies gneisses of various compositions, including granite, monzonite, granodiorite, and diorite, a suite not typically found in Archean greenstone belts. When
the guys realised that model didn't stand up anymore, they didn't just walk away. They said, oh, well, we still have an anomaly here we haven't explained. They weren't model-driven at all.
Now, one important thing to note here is that, at this time, granulite facies orthogneisses were not considered prospective for large, high-grade gold deposits. It's believed that this is the result of devolatilization that occurs at the prograde transition between green schist and amphibolite facies. Some recent work suggests that the release of metamorphic fluids at over 550 degrees C is extremely difficult, which is consistent with observations that most large orogenic gold deposits occur in green schist to lower amphibolite facies terrains. The Tropicana gold deposit was therefore an outlier. Let's have a look at the deposit's geology. The deposit is considered a late orogenic shear-hosted gold deposit, with gold mineralization hosted predominantly within favourable sheet-like cyanitic gneisses interpreted as being derived from andesitic and rhyolitic volcanics. The exact protolith and tectonic setting during protolith development is still being debated today. However, recent work by Tony Crawford of UTAS and Mark Doyle of AngloGold Ashanti has provided some compelling evidence to support one hypothesis. When considering that Tropicana's location is close to a crustal suture and within a Mesoproterozoic mobile belt, they offer two possibilities. One, a passive margin environment forming on the margin of the Yilgarn Craton that was terminated in its early stages of ocean rifting. Or two, a suprasubduction zone assemblage deposited in either a forearc or backarc basin during the closure of an Archean ocean which was subsequently accreted onto the Yilgarn Craton. Now, let's consider the rock types we should expect to see in these two settings. In a passive margin, we might expect to see siliciclastic dominated sequences with basaltic assemblages interlaid with platform sediments including carbonates and maybe turbidites. In an arc setting, we might expect to see rock packages dominated by volcaniclastics ranging in composition from basalt to rhyolite and include minor interlaid pelagic sediments and ocean basalts caught up in the accretionary prism. One important difference between sedimentation in these two tectonic settings is the amount of deposited quartz. When comparing the major oxide ratios of silica versus alumina and silica versus titanium in the host rock package at Tropicana, the data collected shows an extremely tight range for silica in both ratios, with patterns showing no resemblance to the metasedimentary rift package of the Mount Isa block. When compared to rocks in the Central Andean Arc, the host rocks at Tropicana show a much more convincing similarity. And this fundamentally comes back to what was mentioned earlier, a lack of protolith quartz. Unlike most shear-hosted gold deposits, the shear zone at Tropicana is very discrete and was initially not identified. Later work recognised that gold mineralisation is controlled by a system of discrete, high-strain sericite biotite chlorite shears that form a large network which parallels gneissic banding. This shear system forms a network of stacked mineralised lenses with high-grade zones of greater than 3 grams per tonne, which are enveloped by lower grade lenses of greater than 0.3 grams per tonne. On a larger scale, isolated high grade zones and medium grade envelopes converge to form thick composite zones of mineralization. So, The lithologies weren't exactly what the project was expecting in terms of looking for Archean greenstone belt hosted gold. However, the results were disappointing from a geochemical perspective as well.
They drilled over the peak of the soil anomaly, but the soil anomaly was shed slightly to the west, and then the Havana deposit, it was shed significantly to the west. So when they drilled the soil anomaly at Tropicana, especially at the southern end of the Tropicana deposit, they end up drilling over the lower grade portions of it. And then when they drilled the peak of the soil anomaly that was subsequently led to the Havana discovery, that was offset by probably a kilometre or so. And so if you plot up the drill lines over the soil anomaly and then plot the pits where the pits lie, there's a major fault that cuts off Tropicana deposit to the north. One line went immediately to the north of that, maybe 50 to 100 metres to the north of that structure. They did several lines in the middle, and then the anomaly sort of flared out to the south, and they drilled a big line across that. Most of that was outside the deposit footprint. Then they did some broad-spaced lines to the south of that, and they stopped those when they went over the soil anomaly, and if they had done probably 2 or 3 more holes along that first line, they would have drilled across Havana. And then the southern end, they did one long line, and that went to the southern end of Havana, so it didn't hit anything. So if you looked at ways to miss an ore body, the initial air core planning was almost perfectly designed to miss it. They didn't do anything technically wrong, it was just bad luck.
The following year, in 2005, the team had another shot, but this time it was going to be their last chance.
Intention was that we were going to, if those results didn't come in, AngloGold was going to pull over Australia.
The team was offered a final budget to drill 4 diamond drill holes to ensure that the anomalism detected in the previous year's drilling was not associated with a larger mineralised system.
They drilled underneath the peak air core anomalies, whereas I didn't. I chose to drill elsewhere. We'd had a mag inversion done, 3D mag inversion, and I'd noticed that everywhere there was a sort of plus gram hit was a low in the mag model. And so I just picked 5 holes that had the strongest mag destruction, or looked like mag destruction, and that's how I planned the holes. Now, it appears to be subsequently that doesn't seem to have any bearing on the mineralisation. So the 4 holes I drilled were drilled under these air core anomalies that hadn't been looked at, so they were lower grade than the ones that had been targeted by the other guys. But I noticed this mag relationship, which I think has turned out to be a furphy. I actually was on the rig when we logged the first diamond hole that year, and we'd seen biotite and we'd seen pyrite before and chips, and sometimes they were grade and sometimes they didn't. And we logged these holes, and the one I logged was actually the least interesting of the 4, but it had a big zone of alteration, but we didn't really understand what that alteration meant. And so it didn't look that exciting. And subsequent to me drilling those holes, AngloGold decided to reduce their exploration team, and so they retrenched the exploration manager, the district geologist, a few support staff, and it was left to me, one other geo, and a contract geo, and that was the AngloGold exploration team for Australia. And these guys had a 5-week or something retrenchment period, so they were around for 5 weeks. And they finished up on, something like the 1st of August, something like that. And then on the 10th of August, we got the assays back. And I remember talking to the guy, the database administrator, and I came out of my office and he said, you probably want to have a look at these. And I said, what is it? And he said, it's the results for the diamond holes. I went, oh, okay. And I said, is there anything? And he said, just have a look at this. And so he had it on the screen and he was just scrolling down, and it was, 3 grams, 2 grams, 4 grams, 6 grams, 3 grams. And then I went, holy. And he said, it doesn't stop. And so we went on to the next page. And that intercept was 38 metres at 3 grams, and which had a zone of 10 metres at 8 in it. So we knew that from that hole, we knew that we were onto something substantial. And the second one came back in the next day, and it was not quite as good, but it was, 22 metres at 4 grams or something like that. Or no, 22 metres at 2 grams, sorry. We had another high grade zone within it. And yeah, so that was, it was one of the most exhilarating times I've ever felt. The feeling, seeing those results come back and just going, wow, we've actually done something here. It was pretty impressive. And that afternoon, my boss and I sat down and we wrote a paper asking for another $10 million budget from the head office in Joburg, which we got, and the rest is history.
I mentioned at the beginning of the podcast that discoveries are made by teams and not individuals. And this was exactly the case for the discovery of Tropicana. If it weren't for the work completed by WMC and the work completed by Bruce's peers and predecessors, the discovery would never have happened. I asked Bruce what he thought were some of the more significant and perhaps serendipitous factors that ultimately led to the discovery of Tropicana.
Independents were looking for ground in a time when there was a gold downturn, so they managed to get this ground. The ground was vacant. AngloGold were receptive to the idea. I guess that was a partly serendipitous process. They could have gone to a bunch of other people that were less so. That the interpretation at the time was that it was a greenstone inlier, and the one outcrop that they went to looked like greenstone. For me personally, the serendipitous component was that when you look at the drill program, they drilled over the peak of the soil anomaly, but the soil anomaly was shed slightly to the west. At any one of those could have been a turning point where we said, no, this isn't for us. So it was just fortunate. That's just the way the cookie crumbles sometimes. I was lucky in the right place at the right time, and I planned the holes on a reason that turned out to probably be incorrect.
Yeah.
But in the end, it doesn't matter.
One of the things I wanted to ask was, what do you think are some of the more important factors in exploration success?
I think the biggest one is to not be closed-minded and not be model-driven. Whenever I talk to young geos, and I say, I had this exact conversation today. We're looking at some drilling in a program, and the geos, I said, why haven't you planned any holes here? And he said, because I spoke to so-and-so who's been working on the project for years, and they said that structure's it doesn't extend beyond that. And I said, well, what evidence have you got for that? And he said, I don't. I said, well, just because someone believes it's the case, it doesn't mean that's true until you've proven it's true. So if they've got no evidence for it being not continuing, then why make an assumption that it is? And you see that constantly. If you look at any major discovery history, there's always been someone there first, and some convention has come to light why that shouldn't be a good target, and someone's ignored that convention or not known that convention, and they've made a discovery. And so I think that's the biggest thing I can say to young geos is, listen to what your peers are saying, the older people are saying, but if you don't see any empirical evidence for why that argument is true, then it might not be true. It doesn't mean that they're technically not very good. It just means that everyone has biases, and discoveries are made by people questioning those biases. The thing that for Tropicana was that if you talk to people in the early 2000s about a 30 ppb soil anomaly, they would have said that was useless. Why drilling a 30 ppb anomaly? But we had spent a lot of time in the Tanami, and there was very poor gold dispersion in the regolith, and the anomalies were very tight. And if you drill one of those anomalies, you invariably got sort of plus gram intercepts in them. They weren't necessarily economic. Most of them weren't economic, but you nearly always got plus gram intercepts. So you could explain your anomaly. You could say that anomaly has been derived from this source in the bedrock. And the soil anomaly at Tropicana, which can be outlined by 10 ppb, that wasn't explained. And when you did the drilling, you got some numbers that explained that anomaly.
So, that was the story of Tropicana's discovery. During my research into the story, I think I learned a few things that will probably affect the way that I explore in the future, regardless of the commodity. One thing that stood out for me was the contrast between the overarching philosophies behind the exploration conducted by WMC and AngloGold Ashanti. This is an interesting case of one company entering into exploration with preconceived expectations of what they needed to see in order to justify further work. WMC did a fantastic job of first-pass exploration on a large tenement package. However, the pitfalls of model-driven exploration got the better of them. They weren't interested in gold, but would they have passed up the opportunity to discover an 8 million ounce deposit? I don't think so. The reward of discovery was given to a company that was comprehensive in their testing of empirical data. It didn't require genetic concepts, project-scale structural models, or fuzzy logic analysis. Don't walk away from your baseline targets. There are still detectable deposits out there. Another topic the story made me reflect on was geochemical targeting, through the need for comprehensive testing of geochemical targets through understanding of how geochemical anomalies can be offset from a source. The initial work completed by AngloGold was good. However, the work did not account for sufficient geochemical processes that led to major offsets in the anomalies. The early shallow drilling that they completed perfectly missed the deposit, and it reinforced, for me, the need for testing outside of anomalies. The use of magnetic lows as a targeting method was a furphy, but it led drilling away from the nice, shiny soil anomalies that were initially targeted. And this brings me to my final reflection. Try a different approach. The use of magnetics was exactly that. The targeting concept wasn't right, but it led to a variable approach that, in a way, removed a targeting bias that was the geochemical anomaly. A special thanks to Bruce Kendall for kindly accepting the invitation to be interviewed and being somewhat of a guinea pig for this first episode. If you enjoyed this podcast and have some thoughts of your own on any topic in exploration, then please take the time to share them by emailing ben@geoscienceradio.com, and I will do my best to share them on future podcasts. And if you would like to hear more podcasts like this, with better audio, more content, and a wider variety of geoscience-related topics, then go to www.geoscienceradio.com and click Become a Patreon, where you can choose to pay per episode, whatever you like. Any amount will go a long way. For a full list of references for information and music used in this podcast episode, please refer to the website www.geoscienceradio.com. Thank you.